You're back. All right. Is that working? Can you hear me?
You're just fine.
Okay. All right. At least that part of this technology is working, that the connection, the audio hearing camera thing is going. But yeah, no, sorry. A bit of a gong show this morning trying to set up the actual event to make this happen. And it was sort of messing up, and I wasn't able to comment on it. We weren't able to embed the video. And anyway, so I'm sure that doesn't make any sense to anybody but me.
Let's just say all the software is getting updated, and we have no control, and the programmers didn't warn us, because really, why are Google programmers going to warn us?
No. We're out of the loop. Anyway, so hi everybody. My name is Fraser Cain. I'm the publisher of Universe Today, and of course we've got Pamela Gay, Dr. Pamela Gay, my co-host on Astronomy Cast. And if you've never seen this before, what this is a live recording of our Astronomy Cast podcast. This is this weekly podcast that we do. Where we pick a topic in space and astronomy and sort of cover it back to front, and then we stick around afterwards and we'll answer some questions that you might have about space and astronomy. So we're going to get going. We'll record the episode part first, and then when we're finished, we will sort of stick around for a few minutes and chat with you. So if you want to make any comments or questions or feedback while we're recording the show, there's a few places that you can do that. One is on YouTube. So if you're watching this embedded on YouTube, you can make a comment there. If you're watching this on Google+, you can just make a comment wherever you're seeing it on Google+. Or if you see it embedded somewhere and you want to use Twitter, you can just use the hashtag AstronomyCast, and we will catch that there. And then, in theory, we'll sort of, as you make comments and make suggestions and improvements, as I'll incorporate them into the show, and it'll sort of get that feedback going. And then afterwards, like I said, we'll stick around and answer your space and astronomy questions. So we're aware that we're very behind, and we have plans to sort of catch up a bunch of episodes. I've got nothing now for months, so
I hate you with love.
I get nothing. I could record Astronomy Cast episodes all day long, no problem. So Pamela will work with your busy schedule.
No, my Tuesdays and Thursdays look fairly open, so we'll be catching up on shows.
Okay, yeah. So we got, I think we got about 8 episodes to catch up. So, but I got lots of topics. I mean, they're ready to go, and some cool ones too. So we just need to get cracking through them. Okay, cool. Well, let's get rolling then. I'm trying to remember if I've done everything. I've actually completely changed my computer. I was using Ubuntu, and then for some software reasons, I had to switch to Windows. Yeah, I know. I feel dirty. So, I'm still sort of making sure that everything works on Windows. Actually, it works really easy on Windows. It took so much struggling to get everything happening on Ubuntu, but now it's all back on Windows, and it all just kind of works.
Macs are even easier.
Well, I know, but I
cannot
install the Macintosh operating system on my recording computer. So, because the video, doing the Hangout part, that adds a whole level of complexity and sort of performance requirement, and so my MacBook Air can't handle do a Hangout and do the recording and all that all at the same time. While my big desktop, no problem.
Oh, right, GarageBand.
Yeah, the thing that we use to record the show. We're all a little rusty here.
Yeah.
Hi, Thomas. We missed you too. Andres, yes, this is actually live.
Yes.
Actually live. Say when you're ready, and we will get rolling.
If we have 1 or 2 questions while it's slowly open. I don't know how I forgot to open up recording software, but I
did. Because this is very complicated. There's a lot of things to remember, and we don't have checklists?
Well, we do. I just didn't choose to use one.
Oh, okay, all right. You have a checklist that says open up GarageBand there?
Open up recording, but yeah.
Okay, all right.
This is episode 294.
294.
And my last initial is a G, not an H.
Pamela, hey!
Well, it is in some states apparently Pamela to Kai, because you can't say gay. But I don't know if you've heard that joke.
Oh my. I'm going to get the event. So
welcome to watching the sausage getting.
Yeah.
I did remember to reboot my computer so that we won't have all manner of chaos.
I can hear your computer. Bang.
No, you can hear the road construction outside.
Oh, really? No.
Yeah, they're installing light pollution, creating lights that look historical.
Graham, yes, we are going to mention the starring role in Contact and James Bond movies, of course.
Yes.
Okay, I don't expect you to die, Mr. Bond. I expect you to do radio astronomy.
Okay, I have GarageBand all set.
Okay.
And we have one announcement at the head of the episode.
Within the, what's it about?
The Cosmic Quest classes.
Oh, okay, right, all right. Trying to get my event coming in there. Yeah, okay, cool, all right. Hi, Guido. I'm glad we gave you an unexpected surprise. All right, let's get rolling. Nicole,
Dan's
yes.
Like, I love the live parts. Like, oh, you're crazy. We love you too, though.
Yeah.
Okay.
We can't call our listeners crazy. It's not appropriate, Pamela.
But in good ways.
All right. I'm ready. Are you ready?
Okay. Yeah, I'm pressing record. It's recording.
You sure?
Yeah.
Okay. Here we go. Astronomy Cast, episode 294 from Monday, February 18th, 2013. The Arecibo Observatory. Let me try that again. Can we start again?
Yeah, I think I'm using the wrong audio source.
Woo!
So, yeah.
I'm going to write this down. Arecibo Observatory.
GarageBand, why are you doing this to me? Input from Yeti. Is this
Audacity? Audacity.
Is this the mic you're hearing? Do you hear the tapping?
No.
Okay.
I'm really glad we screwed this up. Audacity.
I don't like it.
Ooh,
I don't like
better.
its interface. Okay, I'm recording again, and I'm using the correct microphone. Yes, it's working. Except it's working in stereo. Dang it. Didn't swear online, almost swore online.
Sorry, everyone. Whatever, you all knew what you knew what you were
now
getting
it's
in
going.
for.
Now
All
it's going.
I'm also recording. Okay. Can I start now?
Yes.
Yes. Okay. All right, here we go. Astronomy Cast, episode 294 for Monday, February 18th, 2013. Arecibo Observatory. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. My name is Fraser Cain. I'm the publisher of Universe Today, and with me is Dr. Pamela Gay, a professor at Southern Illinois University, Edwardsville. Hey, Pamela, how you doing?
I'm doing well. How are you doing, Fraser?
Good. Back from a epic 2-week vacation down the west coast of the United States. We went to Oregon and San Francisco and Los Angeles. I went to Griffiths Observatory. I went to NASA. I went to Pixar, the Natural History Museum. It was awesome. And now
and you did all of this with your kids, and you crammed in business and life and everything else.
Yeah, exactly. It's a business. It's a tax write-off. Yeah. So no, it was good. It was really fun. If you've never done that trip, if you've ever gone down the west coast of the United States, I highly recommend it. It's a beautiful chunk of the world. So
it really is. So is Western Canada and Alaska. So really, just like start
the whole west,
Bering Strait and
but you can't drive. Yeah, you pretty much can't drive north of Vancouver along the coast like that. Yeah, so you got to take a ferry.
Wow. Okay.
But no, you have an announcement this week.
I do. So we had great success last fall teaching a series of different classes through CosmoQuest. It's our Cosmo Academy program, and we are offering 2 more classes this spring. The first one is Stars and Stellar Evolution, or actually it's called The Sun and Stellar Evolution, but it's really stars. This is getting taught by our own Ray Sanders, Dear Astronomer. And that course runs from April 15th to May 8th, and you can sign up for it at cosmoquest.org/classes. There's a link to the Eventbrite page. And then we also have Dr. Matthew Francis, who on Twitter is Dr. Mr. Francis. It's really Matthew R. Francis, but really it looks like Dr. Mr. Francis. He's the director of our Cosmo Academy program, and he's in the process of writing a new book on cosmology and is bringing his expertise to the classroom. He's going to be teaching an introduction to cosmology class. Both these classes are limited to just 8 people, so this is a very intimate experience. Nicole Gallucci and I will pop in and out on a regular basis. And so if you're interested in learning and you have spare money to take some classes, we're sorry, we can't do this.
Yeah, there is a fee for these. Yeah.
We have to pay our instructors. But these are chances to learn from people active in astronomy and who are solid communicators of astronomy. So please sign up, join in, and I hope to see you in our classroom.
And it's all done in a Google Hangout, right? Yeah.
Yeah,
so
we do everything through Google Hangouts.
Yeah, and that's great. So only 8 slots with each one, and I know they're going to fill up fast. So if that's in any way interesting to you, go and sign up. Is there a different fee for each one? Is there
No, it's both the same fee. And to be entirely honest, in trying to figure out what to charge, I looked at the typical prices of yoga, horseback riding, ballroom dancing, and piano lessons.
Right.
And we are completely competitive with any other sort of extramural class you might take.
Okay. Well, let's get on with the show then. So the mighty Arecibo Radio Observatory is one of the most powerful radio telescopes ever built. It's certainly the largest single aperture radio telescope on Earth, nestled into a natural sinkhole in Puerto Rico. We're celebrating the 50th anniversary of the construction of the observatory with a very special episode of Astronomy Cast. 50 years.
Yeah. It's kind of awesome that we've been building monstrous facilities like this for so long, and it makes you really think back to the fact that 50 years ago, well, that's not too different in time. It's the same generation that built the Hoover Dam, that built the St. Louis Arch, that built all of these giant works programs across the United States. And one of these giant works programs was building a giant radar dish out in Puerto Rico. And it took about 10 years to sort out all the details of what was needed, and it was finally opened in November of 1963. And we're still using that sucker today. It's constantly getting updated both on the software side and, as monies allow, on the hardware side, so that it continues to be a competitive facility capable of doing science that nowhere else in the world can the science get done.
Now, it is a very special instrument. So can you sort of explain a bit about if you were to, have you ever visited it?
No, I haven't.
No. What is it? And I know we've seen it in movies and film and stuff, but what is the observatory? Because it's pretty neat.
Well, at the most basic level, it's nothing more than a satellite dish like you might use for getting television and internet. It is capable of both sending and receiving radio waves. But what makes it special is this sucker is huge.
Mm-hmm.
There's really no other way to put it. It is 300 meters or 1,000 feet in diameter. It's built into a natural sinkhole in Puerto Rico, which is actually part of why we chose to build it there. Was you don't want to have to dig a hole for something like this.
1,000 feet across. Yeah.
Right. So they found a natural hole. And it's a spherical spherical reflecting surface. And this is actually very important. When they were first working on designing this, the initial design was strictly to use it to study the atmosphere. And they were originally going to build a parabolic, a mirror that only focuses at a single place above the reflecting surface. And that would mean that it could only observe straight up. Now, that really limits what you can see, especially since planets aren't necessarily going to be directly above this object. So as the project continued to move forward, they actually put out a request for proposals on how can we redesign this so that you can actually look at different parts of the sky without being able to move the dish. You can't move 1,000-meter dish or a 1,000-foot dish, 300-meter dish. It's just, that's a lot of mass, and it would deform as you moved it.
Right.
So they've built this beautiful system out of aluminum sheets. They're suspended on a network of cables, and by switching from a parabolic mirror that only focuses in one place to a spherical mirror that has the exact same edge image issues everywhere you point, you can actually, over a spherical dish, move your focus point around, and as far as it's concerned, there's still part of a sphere below it. But then you have to figure out, how do you suspend that thing that you're moving around so that you can move it so carefully, so gradually, that you can track the Earth's rotation precisely. And the system that was eventually devised, there's a series of pillars. It was designed with 4. They only put up 3 because that's what they realized was all they needed. There are these 3 towers that have cables coming in, and they suspend the receiver for the system, and they can move the receiver around on a series of tracks. And it's all extremely precise. And what's really funny is all of these bits and pieces have an acting role in the GoldenEye James Bond movie, except instead of pointing at distant quasars, they're pointing at a nearby satellite that's going to blow up the Earth or something.
Right, and they need to fight on these various parts of the observatory.
Right. It's really kind of funny.
So, this is a bit of a mega project. It was probably a very complicated and very expensive undertaking to make something that large.
Yeah.
What was the original science goals of the observatory? What did they plan to use it for?
Originally, they were just looking to study the Earth's atmosphere. You can bounce radio signals off of our atmosphere, and depending on the wavelength of the light, they'll bounce off of different heights in the atmosphere, and based on how they come back, you can measure the turbulence pockets, the cells of different atmospheric characteristics as it goes up. So it's a very detailed way of observing all the different layers in our atmosphere. But then as they work to redesign it to allow tracking and guiding, they added in the ability to do active radar, to bounce radar off of nearby planets the same way we might image a satellite orbiting the Earth with radar, or heck, police radar beam things all the time.
Right, so you're using it to transmit radio waves at a surface and then detect the bounce back from that surface, which is amazing. To be able to send, it's a transmitter.
And what's kind of cool is, up until Arecibo was up and working, we didn't actually know accurately the rotation rate of the planet Mercury. It was only in 1965 that we realized this little world wasn't as tidally locked the way we thought it was. So it turned out, we figured out from the radar returns, that it rotates every 59 days instead of the previously thought every 88 days. So just a few years after its opening, it was already completely changing how we looked at nearby planets. And in fact, it was the instrument that was able to provide us our first maps of the planet Venus, admittedly only at a resolution of 1.5 kilometers, but it still mapped Venus in radar light for us.
But you can't move that observatory at all. You can only move that detector array that's above it, right? So, for example, if they wanted to observe the surface of Venus, how would they do it?
So luckily, they built this observatory fairly near the equator. Puerto Rico is a nice equatorial island. And that means that it's looking up at that part of the sky that all the planets occupy, for the most part. The sun and the planets all vary back and forth from plus or minus roughly 24 degrees in between the tropics of Caprica and Cancer. And luckily, this observatory, by moving the receiver around, the receiver is able to look at light that's coming in at a different angle depending on where they put it. And by steering the receiver around, they can actually look at objects within plus or minus 45 degrees of straight overhead. That gets them all of the planets, and it gets them a good chunk of the sky. And truth be told, any observatory, you really aren't going to be pointing the telescope more than 45 degrees down from straight overhead, because you're just looking through too much atmosphere if you do that. So even though you can't move the base of the telescope, you can move the receiver and still steer around on the sky.
So it's possible then, obviously, to get the radio emissions from Venus, coming from Venus, they bounce off that spherical array up into the actual detector, which has been positioned to get that image. But how do they actually look? I'm putting air quotes in the video. How do they look at Venus? Because it's radio, right? So it's not
right.
It's not like you're going to like look through your lens, your eyepiece at this image, this radio image of Venus. So what do they actually see?
It's even crazier than that. The thing people don't really think about with radio telescopes is this is a single pixel detector. You are
one pixel.
One pixel. So you have to move the beam around on the object, and it's by recentering that one pixel over and over and over that you're able to build up the image. So it's kind of a longer, more elaborate process than what many of us are used to. But with Venus, the way they do it is they actively shoot radar beams at Venus and then measure how long it takes for that signal to get back. And by shooting these beams of radar at Venus over and over and over, they can build up the elevation differences from place to place across the surface. And one of the kind of frustrating things is this is a very powerful device, so we could conceivably use it for more than just the nearest planets, but we run into this problem that objects like Saturn, the amount of time that it takes for the radar signal to get back is so long that by the time the light has gotten back, Saturn's no longer in the field of view of the telescope.
Right. I mean, you can just imagine the math here. I mean, they're detecting elevation differences on Venus that could be a few, 1,000 meters less, probably. And they know, and it takes light, I don't know, 4 minutes, 2 minutes to get to Venus and then back, and Venus is moving, and Earth is moving, and Earth is rotating. I just can't imagine how complicated it is for these people to do this work. It's insane.
It's just geometry.
It's merely really, really complicated, advanced geometry. That's all.
Yes.
Yeah. So anyway, kudos. So okay. So I mean, it's mapped the surface of Venus. It's determined the speed of orbit, speed of rotation of Mercury. But I think when a lot of people see the Arecibo Observatory, they think contact, they think aliens. They think search for life. So how has it been sucked into that project?
Well, truth be told, it was actually used for the SETI at Home project. So if you remember back in the 90s, there was software.
And we will catch that there. And then in theory, we'll sort of, as you make comments and make suggestions and improvements, as I'll incorporate them into the show, and, it'll sort of get that feedback going. And then afterwards, like I said, we'll stick around and answer your space and astronomy questions. So we're aware that we're very behind, and we have plans to sort of catch up a bunch of episodes. I've got nothing now for months, so
I hate you with love.
I get nothing. I can record Astronomy Cast episodes all day long, no problem. So Pamela will work with your busy schedule.
Yeah, no, my Tuesdays and Thursdays look fairly open, so we'll be catching up on shows.
Okay, yeah. So we got, I think we got about 8 episodes to catch up. So, but I got lots of topics. I mean, they're ready to go, and some cool ones too. So we just need to get cracking through them. Okay, cool. Well, let's get rolling, man. I'm trying to remember if I've done everything. I've actually completely changed my computer. I was using Ubuntu, and then for some software reasons, I had to switch to Windows. Yeah, I know. I feel dirty. So
control in the programmers didn't warn us, because really, why are Google programmers going to warn us?
We're out of the loop. Anyway, so hi everybody. My name is Fraser Cain. I'm the publisher of Universe Today, and of course we've got Pamela Gay, Dr. Pamela Gay, my co-host on Astronomy Cast. And if you've never seen this before, what this is a live recording of our Astronomy Cast podcast. This is this weekly podcast that we do. Where we pick a topic in space and astronomy and sort of cover it back to front, and then we stick around afterwards and we'll answer some questions that you might have about space and astronomy. So we're going to get going. We'll record the episode part first, and then when we're finished, we will sort of stick around for a few minutes and chat with you. So if you want to make any comments or questions or feedback while we're recording the show, there's a few places that you can do that. One is on YouTube. So if you're watching this embedded on YouTube, you can make a comment there. If you're watching this on Google+, you can just make a comment wherever you're seeing it on Google+. Or if you see it embedded somewhere and you want to use Twitter, you can just use the hashtag AstronomyCast. You're back. All right. Is that working? Can you hear me?
You're just fine.
Okay, all right. At least that part of this technology is working, that the connection, the audio hearing camera thing is going. But yeah, no, sorry, a bit of a gong show this morning trying to set up the actual event to make this happen, and it was sort of messing up, and I wasn't able to comment on it. We weren't able to embed the video, and anyway, so I'm sure that doesn't make any sense to anybody but me.
Let's just say all the software is getting updated, and we have no